College from EC department. Today I will explain about the Newton's law of cooling. Newton's law of cooling temperature problem, physics, temperature analysis. Step 1. Given information, the body is air cooling in air. The following conditions are given: air temperature 20 degrees Celsius, initial body temperature 100 degrees Celsius, temperature after 10 minutes 80 degrees Celsius. We need to find the temperature after 20 minutes and when it reaches 40 degrees Celsius. Find temperature after 20 minutes. Find time when temperature reaches 40 degrees Celsius. Apply Newton's law of cooling formula. Use given initial conditions. Solve the differential equation. Step 1. Newton's law of cooling. Newton's law of cooling describes how the temperature of an object changes over time. The law states that the rate of temperature change is proportional to the difference between the object's temperature and the ambient temperature. dt by dt equals to minus k of T minus Ta, where capital T is the object's temperature, Ta is the ambient temperature, and K is cooling constant. Step 2. Set of the differential equation. Using Newton's law of cooling, the solution takes the form T of T minus T of A equals to T naught minus Ta e power minus Kt, where Ta equals to 20 degrees at air temperature and T naught equals 100 degrees Celsius initial body temperature. They give us T of T equals to T of T minus 20 equal to 100 minus 20 e power minus Kt. T of T minus 20 equals to 80 e power minus Kt. Step 3. Calculate the cooling constant K. Using the condition T of 10 equals to 80 degrees Celsius, we substitute into our equation 80 minus 20 equals to 100 minus 20 e power minus 10k. 60 equals to 80 e power minus 10k. Dividing both sides by 80. E power minus 10k equals to 60 by 80 equal to 3 by 4. Taking the natural logarithm, minus 10k equals to log of 3 by 4. K equals to minus 1 by 10 log of 3 by 4. 1 by 10 log of 4 by 3. Step 4. Write the compare temperature equation. Now we can write the complete temperature equation by substituting our values. Since T0 equals to 100 degrees Celsius, Ta equals to 20 degrees Celsius, and K equals to log of 4 by 3 divided by 10. T of T equals to 20 plus 100 minus 20 e power minus Kt. T of T equals to 20 plus 80 e power minus Kt. Substituting K equals to log of 4 by 3 by 10. We can write this is as T of T equals to 20 plus 80 into 3 by 4 cap T by 10. This equation gives us the temperature at any time T minutes. Solution. Newton's cooling law part A. Find the temperature 20 minutes. T of 20 equals to 20 plus 80 3 by 4 whole square. T of 20 equals to 20 plus 80 into 9 by 16. T of 20 equals to 20 plus 45. T of 20 equals 65 degrees Celsius. The temperature after 20 minutes will be 65 degrees. Verification. Checking our 20 minutes results. Let's verify our answer by examining the cooling pattern. 10 minutes temperature drops 100 degrees to 80 degrees Celsius. A decrease of 20 degrees Celsius. Second 10 minutes temperature drop 80 degrees Celsius to 65 degrees Celsius. A decrease of 15 degrees Celsius. This decreasing rate of cooling confirms Newton's law of cooling is working correctly. As the body gets closer to the ambient temperature 20 degrees Celsius, the rate of heat loss slows down. The temperature difference drives cooling, so smaller difference means slower cooling. Step 2. Set up the equation for T equals to 40 degrees Celsius. For part B, we need to find when T equals to 40 degrees, substituting need to into Newton's law of cooling. 40 equals to 20 plus 80 into 3 by 4 into T by 10. Subtract 20 from both sides. 20 equals to 80, 3 by 4 whole into 2 by 10. This equation will allow us to solve for the time t when the body reaches 40 degrees. Part B solution. Finding time when t equals to 40 degrees. Setting t equals to 40 degrees in our cooling equation. 40 equals to 20 plus 8 into 3 by 4 for t by 10. 20 equals to 80 into 3 by 4. Taking natural logarithm of both sides. T by 10 into log of 3 by 4 equals to log of 1 by 4. T equals to 10 into log of 1 by 4 divided by log of 3 by 4. T equals 10 into log of T equals to 48.2 minutes. The body reaches 40 degrees after approximately 48.2 minutes. Summary. Final answers Newton's cooling. Based on your calculations using Newton's law of cooling, temperature after 20 minutes 65 degrees Celsius. The body cools from 100 degrees to 80 degrees in the first 10 minutes, when continues cooling to reach 65 degrees at the 20-minute mark. Time to reach 40 degrees Celsius, approximately 48.2 minutes. Using your mathematical model with k equals to 0.0288, we determined the body will take about 48.2 minutes total to cool from 100 degrees Celsius to 40 degrees Celsius in the 20 degrees Celsius ambient environment. Thank you for all.